Well, hello everybody. Welcome to the Multispectral Data Visualization and Extraction with QGIS section. I'd like to welcome Taylor Nelsen to all of you. She's a fantastic colleague over on the UC Davis campus, and I'll let her tell you more about herself and her program and what we'll be doing today. Thanks, Taylor.
Okay, well, I will jump right in. This is a little bit of introduction. I am an assistant specialist in the plant science department at UC Davis. And so my specialty is not necessarily GIS, but I have a geography undergrad degree and then did a master's in horticulture and agronomy at UC Davis. So the drones and the QGIS is a tool that we use quite a lot in our lab. I think I'm probably one of the top users at UC of like the number of flight hours because we are ubiquitously using these tools. But I wouldn't consider myself an expert at all, despite teaching quite a few of these workshops. So throughout the session, we'll have time to like stop, check in. You can ask questions on the Q&A window, but if you have questions later, feel free to reach out to me. So we'll do a quick introduction of a few minutes of where we're going with kind of this whole demo.
Taylor, just a heads up, your mic is rubbing on something, so it's blurting out once in a while.
Maybe my hair?
Yeah, maybe just, if it's a lapel, scratching. Okay. There you go.
Let me know if that fixes it. I can always take my headphones out.
Now it's,
Okay, so we're going to do, there's two sections, or actually three sections to the demo, and we'll do a hands-on data visualization with drone data. We'll have a quick break, then we'll do hands-on with data extraction, and then I'm going to demo how to use R scripts in QGIS for high throughput data extraction. So the first kind of output we're going to have is a map, and just to give you a little background of what the image is we're looking here, this is actually a triticale field. A triticale is a wheat rye hybrid. And the farmer here had tomatoes growing, and then he wanted to apply no nitrogen at all. But our experiment here was to test whether nitrogen would be needed or could benefit the crop. So in each of the squares, you can kind of clearly see in the image, we added additional nitrogen. And then we want to be able to compare those squares to the rest of the field to make a recommendation. Our second output will then use the same image, but we're going to actually extract the data, create shape files, and then get the values from the NDRE image. And then what I'm going to demo at the end is to use the R script to get a more uniform, create a shape file and extract data for something like a small plot trial or any kind of uniform stand of, this works for kind of these plots of grain. We've done it with almond trees that are already uniformly planted or any kind of thing such as that. Okay, so let's see, I'm gonna have to turn my video off to show the next part. So if everyone has the link here, I'm gonna be going through this, the website here that's shown on the screen and the steps through here. Everyone should have already got through setting up where you have installed QGIS and downloaded the data. And we're going to start with number 2 here, multispectral data visualization. So if you want to follow along, I will reference this as I go. So we're in this first one, we're going to have a new project in QGIS, add a raster layer, color that raster layer, get to know some of the best practices for image display and communication, and then export the styled raster image. So if you don't already, I would open QGIS. I'm going to pull it over there. Open it up on your screen. It does take a few minutes to start up sometimes. If you already have it up and you have a project open, we'll want to kind of save this project. I haven't even saved it yet. Save our work as we go. I'm going to save it on my desktop, and this will let you know what the folder looks like if you download it from the site. You should have an example data in R script. And then I'm gonna create this project here of multi-spec analysis.
Taylor?
Yes.
While people are kind of loading this in, maybe do you want to try disconnecting your headphones, because like some people might still be having problems hearing you? Yeah.
And just as a comment to the to everyone in attendance, if you have any questions, please feel free to add them to the Zoom chat window. And you can also put your hand up in the participants pane as well. But we'll be watching the Zoom chat window closely to answer whatever questions we can, either just in text form or relay them to Taylor Nelsen for comment.
Is that sound better?
Yes.
Yes.
Okay. We'll just go without headphones then. Okay, so the first thing we're gonna do is add that raster layer. And to add a raster layer in QGIS, I'm assuming everyone is somewhat of a beginner, so as we kind of go through this data, we'll also go through the QGIS GUI and how to use it. So up here on this ribbon, we'll go to layer, add raster layer, or it's a Control-Shift-R on Windows. So if you choose that, it should open the data source manager. And here you can see you could choose different types of data here if you wanted to import a different type of data. But you want to make sure the file radio button is selected here. And then we're going to navigate to the raster image that we're going to be working with in the downloaded folder. So let me go to my desktop here. And this is actually in the example data folder, and it should be called Solano 2 2020 NDRE. So I just also want to note while I'm in here in this downloaded data folder, if you get really behind, before we go on to the second section, there is a new QGIS file that you could just open and you'll be on the same page as everyone else. And we also have, there's a final version QGIS file as well that will open and have everything that we've done, so you can look back and see what kind of errors you potentially made. So I'm going to open this NDRE TIFF file. And you have to press add to add it to the QGIS window, and then press close. So at this point, everyone should be seeing a grayscale image on their screen. I'm gonna try doing a check-in. Let's see if that's not working. Can you put up the red no on your window?
So you should be able to find that in your participants pane. Once you've selected it and you hold it there for a while, you may have to re-click it or select clear all to get rid of your check marks.
Okay. If you're having trouble, please let the helpers know. I'm going to keep going. So the first thing we're going to try to do is to color this raster and look at some of the properties of it. So you right click in the layers panel here, the NDRE layer, and go to properties. It'll open up property information about this layer. You can see the projection here, which will be an important later on, as well as the unit of the measured meters, the width and height of the image, and all sorts of information about it. But we're going to go to the symbology section here. And as you can see right now, it's single band gray. And we can't actually necessarily see all the detail we want to, or if we wanted to share this with a practitioner to the farmer or someone, we want to color it. So I'm going to go under here to single band pseudo color. And that should open this where you have a color scale here. Yours might not look exactly like mine. This is the default color that I use because red is a good indicator of poor plant health, whereas green is a good indicator of, you know, robust plant health. And since we're mostly working with plants in the lab I work with, that makes sense. But you'll want to have a linear interpolation because it's not a discrete data, it's continuous data. And then if your color ramp isn't already in this color scheme or you want it to be in a different one, you can use the drop down menu. And you can see you can invert it, you can choose a different one, or you can go to all color ramps. You can see there's a bunch of different options. The one I'm using here is called red, yellow, green. So if I go down here, I'm going to apply it. If I'm happy with the color scheme that I have.
Hey, Taylor, when you get to a pause point, your audio garbling is in and out, but it's a little bit worse than it was before. So maybe try something else.
Yes, it sounds like your bandwidth might be limited. Your connection might have it.
Let me try to call in.
Yes.
Real quick.
And while she's doing that, I can answer a question for John on the chat line. The red green doesn't work for pantopic color blindness. Does anyone have any suggestions for that? This exercise actually has a preview of what the mapping elements look like in color blindness that Taylor will get to later in the exercise. And so that will be covered. Yeah. And while she's doing that too, I can comment a little bit on QGIS. I used to use this some years ago. ESRI likes to get people hooked on their software by providing it close to free for academia. And so a lot of people use it, but when you go to the private sector, it jumps from say $100 a year to like $5,000 a year or more, depending on the extensions you're willing to pay for. And the thing with QGIS is it does the vast majority of the same things that ArcGIS does. And in fact, some things it does faster. The thing with the difference between the two is that ArcGIS just has more integration with cloud options and other Esri products.
Also, sorry, back to the color blindness. I think also within properties, the Viridis color ramp is particularly good for color blindness if you want like a very specific example. I think that one is pretty universally used for that kind of thing. Also with grayscale printing.
Mm-hmm.
Okay, can you guys hear me now?
Yeah, with an echo though. You might have to turn off your other sound on that is available.
Okay, is that better?
Yes, that sounds great.
Ooh.
Fingers crossed. Such is the age of virtual teaching.
Okay, so hopefully everyone's got a color now that you like. You press apply and okay to close that window. So if you're following along, we have a check-in and everyone should have a colored raster image. So I know people were talking about this, about colorblind friendliness. That's one of the kind of top image display best practices that we want to be aware of. So actually QGIS does have a way to do that. If you go under view up here at the top, and then it's under preview mode, you can simulate multiple different types of color blindness, as well as what grayscale looks like. So you can see here, that's what it might look like in this color scale to someone with a color blindness. So in general, you want to choose colors that are high contrast for the features you wish to highlight. And right now, our features aren't the most contrasting. And so that's one of the next things we want to do. So I'm going to turn it back to normal. So one of the ways to highlight the features of interest, which really are these dark greener nitrogen-rich areas, we want to make sure we don't include areas that are not of interest, such as the roads and the other field here, a building. It's just kind of the edges, because when you're flying a drone, you want to get plenty of overlap, especially over the edges. So one way to do that is to clip to an area of interest. So in order to do that, we'll go to raster. And then if you go to extraction, and we can choose clip raster by extent. So that's going to pull up this window. And pretty much what we're going to do is just clip the image, crop it, just like you would in any photo tool. So we'll want to make sure our input layer is that raster layer that we have. And then we can choose the clipping extent. You can choose the canvas extent, which would be the entire canvas. The layer extent would be the entire layer, which that's not what we want. So we'll want to select an extent on the canvas. So if you click that, it's going to give you a little crosshairs cursor. And you can use that to draw a box around the area of interest. So if you do a left click and drag, that will be your cropped area, the area highlighted on my screen. So I'm going to look at just this one area in the field first. It's kind of just a demonstration. When you release your click, you'll go back to this window and it should give you what that box, highlighted box, looks like. So right now it's just going to save it to a temporary file. It's not going to be saved on your computer. And if you closed your QGIS application at any time and tried to open it back up, this file is not going to be there. If you wanted it to be there, you could actually go here and save it as a file. But we're just going to change it as a temporary file and then open it after running. So I'm going to press run. And you can see it says algorithm clip raster by extent has finished. And up here in the layers panel, I now have a clipped extent. So you should now see this little grayscale box of just the area that was chosen. And if you want to try coloring this area, then we should see that there's actually a lower range of values. So since this is my area of interest, my values only go from about 0.4 to 0.6, whereas before they were from less 0 to 0.6. So just by having a smaller range of values, I have a wider amount of colors that I can choose from and have more contrast in colors. So I can color that, but really what I want to know personally from this, for the image here, is this range of values for the area of interest. So I'm going to use that range of values to then color the entire field. I'm going to go back into properties here. And I can set the minimum and maximum. Right now it's the minimum maximum of the whole image, but I'm going to set my minimum maximum to 0.35 and 0.65. So I know that maybe that square isn't representative of the entire field, but it is just the area of interest that I want. So if I apply that, you can see I already have a lot more contrast within the field, and all of these are red on the outside. I don't really want this here. And so you have two options of, you could uncheck it, or you can move it beneath the layer. So I'm just going to uncheck it. And it will go away. So before finalizing of this image, I don't really want all this red area around the outside. So I'm gonna go back into properties and remove that red area. And it's actually a pretty quick fix. I can choose right here to just check clip out of range values. So anything that's below 0.35 or above 0.65 is just going to be clipped out of the image. Press OK. Everyone should have an image that looks something like this. So color-wise, that's probably, we've introduced some contrast in the image and got rid of the areas that we don't want to see. But if we want to share this image, we definitely want to make this project into a map and include a legend. So I'm going to pause there, and if anyone puts up their green check mark for yes if you're here, or your red no if you still need more time or have questions.
I see a variety of green check marks and a couple thumbs up, but
Okay.
no red check marks. So that's a good sign, or thumbs down.
Okay, well, let's keep going then. So to export this image, like maybe we just want the image itself before we even make it into a map, even though I recommend including some sort of legend if you're going to share with someone. We can go to project, and then here under import export, we can export the map to an image or a PDF. I'm going to say I want to export it as an image. It gives you a couple of options here, such as your DPI, the scale. Right now, it's set to the map canvas extent. So whatever I'm seeing here is what I'm going to get in the image that is exported. I don't really want, if you wanted the georeference information, you can include it or not. Or you also have the option here to copy it to a clipboard, which is, I use a lot when I make a styled image and then I go and put it in a report or onto a PowerPoint, and that's really all I want to use it for. If I press save here, we want to save it here as yes. Image 1 from this thing. And so at the top here, you should get this green dialog bar that says it was successfully saved and where it was saved. So before it goes away, you can click that, or you can go into your desktop and see where it was saved. It should be right here. So. But really, we do want to have a legend or a scale bar and some different pieces of information associated with. So before I'm moving further, I'm going to go ahead and save this. And then I'm going to start what's called a print layout in QGIS. So if you go under here under project, under new print layout, or it's Control P, it's going to ask you to give a unique title here. And then it should open up this pretty much blank canvas. So we need to add the map and all the pieces to the map. And all of those things are going to be under Add Item. So under Add Item, the first thing we definitely want is the map. And again, a lot of these things work similarly in QGIS. It's going to give you that crosshairs and you're going to drag across of where you want to put your map. And I'm just going to say, take up the whole page. And then there's my map. The one thing that sometimes trips people up here is if you say you are looking over here and you're zoomed in here, and then you go, and that's really what you want on your map, or if you don't want that on your map, you can make this map mirror what you see in the main window by going right here under Set Map Extent to match the main canvas. And so then I get a zoomed in version right here. I could also view it and do different things. So I'm going to go back to the main extent, and to do that, if I right click my layer and press zoom to layer, it'll all take you to the full view of the layer. But I will have to re-click this in order to get the whole thing. So I also want to probably add a scale bar and an arrow. So also under add item, I can go ahead and add a scale bar here. The scale bar is in meters since my projection is in meters. If you wanted to change that, you could change your scale bar units over here, or you could change your projection. I'm going to add a legend and just drag to create that. So right here, I probably don't want to include the clipped extent as well as this, since it's not showing up on my map and I don't want it to be a part of it. So there's two ways I can get rid of it. I can go, and probably the easiest way is to go under here and just remove it, since I don't want it anymore. And I can just right click the clipped extent and then remove layer. So if I go back under here, it now disappears. I want to add a north arrow, and it will automatically point north, which is conveniently that way on this field. And then maybe the only thing I would want to add as well is a label on here, so that I can drag and drop and then type in here that I wanted to say this is NDRE 220. And I can change the properties of that within this item properties panel. So my font is right here, and its font size is 10 right now, but I probably want to be something like 28. And then here is, I have a little bit more information when I export this map. So in order to export it, it's very similar. I can save it up here, and then when I open the QGIS project again, that will be saved as a print composer within the project. But if I do want to export it, I can go under layout and export as image or PDF, and we will do PDF this time. And the file name will take the default of whatever you named your print composer. I'm just going to save it. And then it's going to give me an options window here. I don't necessarily want the georeference information on a PDF. You can create a geospatial PDF, and then save that. So if I click up here, it should take me directly to where it is in my file structure. And I can open that up and double check that it exported correctly and it is what I want it to be. Okay.
Taylor.
Yep.
There's one other little feature that didn't used to be there, but move item content. The fourth button over down on the left for moving the map around. I found that really useful.
Oh, this one right here?
No, far left bar on the fourth one down below the hand and the magnifying glass. The far left.
Right here.
Yep.
Yeah.
Yeah, that's pretty handy too. And
So that allows you to just move this content. Oh, okay.
Yes. Yeah, that's it. That didn't used to be there. I'm happy to see that the layout functions are getting much more user friendly with things like
QGIS has improved significantly over the last probably 5 years because it is an open source. I think it started out being kind of clunky, and it in some parts of it still are, but it's getting to rival ArcGIS, I think, in some of its features. So, okay. Well, are there any? Let's everyone put their green check marks or red nose up if you have reached this point and are ready to move on. Okay, getting mostly green check marks. So I'm going to close the layout here and go back to my main canvas. If you're following along on the kind of instructions online, we're going to the next section, the multispectral data extraction. And if you somehow got behind and you want the colored image, you can open the QGIS file that starts here. So in this section, we're going to create a shapefile, and then we're going to edit the features and data of the shapefile layer. And we're going to use that shapefile layer to extract data from a raster image. I'm a little bit ahead of schedule, so we might start this and then take a break because this part is a little bit more involved than the previous section. Okay, so we're going to use the same image here, and we're going to create a shapefile that defines these areas of interest as well as areas that are right next to them that we can compare them to. So to create a new shapefile layer, you'll want to go under Layer, Create Layer, and then New Shapefile Layer. So here we'll actually want to probably save this layer because we're going to be using it later on to actually extract the data. So I'm going to go under File Name and click the 3 little dots. And it's kind of a weird thing with QGIS. If I actually just typed in like my name of my file in the file name box, it will throw an error and not let you. You have to actually give it the full path. And the easiest way for me to do that is to go to Browse and then put it in my data folder. So if you do get stuck on this section, there's also a shapefile that I already created called the low throughput shapefile that is the shapefile we're going to create so that you could move on if you wanted to. I'm going to make this number 2 because it should be exactly the same thing. So we're going to make a shapefile that is a polygon, but you have different options under here if you ever wanted to create a point shapefile, a line shapefile. And when we're creating the shapefile, we can also create or add the coordinate reference system. So right now it's set here to WS 84, so like lat long. But the main thing is we want our shapefile layer to match the coordinate reference system of our multispectral image. So I'm going to back out of this and double check what the coordinate reference system of my image is. And it's under properties, like we looked at when we were styling the image. So it's, again, under the information. And so right here, you can see that it's UTM zone 10 north. And if we remember this code 32610, we'll be able to type it into the search bar when we're setting the coordinate reference system of the shapefile.
Taylor, a brand new function is that you have a drop down to pick from your frame, which is the first file that comes in, kind of like Pro does or ArcGIS does as well now. It's a huge, huge time saver. It's neat.
A drop down where?
Yeah, from
From here?
When you, yes, there you go. Click down, yep, there, and you can have it in the
Yeah,
project.
so yeah, these ones are like ones I've used recently. Or it's like this one's the project coordinate reference system because our image is that and we saved it in the project. But if it's not showing up for you, you can always click the little world button here and it'll let you search through all of them and you can type in here. But yeah, they did add that recently that'll save what you have. I'm gonna choose that one, go back and polygon. So here you can also name the fields. So if you have pretty much in the shapefile, we can create, the data table that goes with it, and you could create the fields here, but I'm going to actually show you how to edit those later. So once you have it saved where you want as a polygon with the correct coordinate reference system, then you can press OK. No, I'm just going to overwrite mine. But now you should have something, your shapefile showing up in your layers panel, but nothing is showing up here now. It's pretty much a blank shapefile at the moment. So in order to edit the shapefile, we need to go to the little pencil here to toggle the editing on. Now, if you haven't used QGIS or set it up before, this is part of the digitizing toolbar. And then later we'll use the advanced digitizing toolbar and the shape toolbar. So to get to any new toolbars, you can go under View, Toolbars, and this is a whole list of toolbars that are installed on my QGIS, but most of them come default. So we'll want to make sure we have the digitizing toolbar, the advanced digitizing toolbar, and the shape digitizing toolbar for this section. So in that digitizing toolbar, you can see a little pencil, or you could right click on the low throughput shapefile layer and go to toggle editing. So once you've toggled editing on, that's when you can actually access the different pieces of the digitizing toolbar and the advanced digitizing toolbar. So we don't have any shapes yet. And I'm going to show you a couple ways to make the shapes that we want. So I'm going to zoom into this area since I want to create a box here. And you can use a little magnifying glass and draw it around that area. The first way is to use this add polygon feature. So once you click that, it's going to give you the crosshair with a circle around it. And you can just click around to the vertices of your polygon. So if I left click, is going to create one vertice, and then I can start dragging it to create the rectangle. Once I have the rectangle, to close it and finish it, I'll want to right click, and it's going to pop up this dialog that asks me to fill in the feature attributes. So if I had other things other than ID, I could enter them in here, but I'm just going to give this an ID of 1. So another way to create a feature is to use this shape digitizing toolbar. And it has some of the basic shapes here. If you go under this one, it's add a rectangle. And since when we set these up in the field, we made sure that they were right angles, and it is a rectangle that is exactly like 90 by 180 feet. So if I go under here, there's a couple different ways, but if you want to add a rectangle from 3 points, I have to just use the crosshairs to click 2 points, And then my third point, it will drag directly down at the angle that I clicked the first 2 points. But then again, I want to use the right click in order to close and finish that polygon. Say that one's 2. So now I have 2 polygons, but I don't know if I want to create those in the same way for all of these different sections or not, and pretend maybe I want to move these, because now that I think about it, I actually want this one above the other one, because when the farmer's planting grain, he's going in a line and something else might have happened over here. So in order to be consistent, I want to move it. So in order to move a polygon that you created, we still want to make sure we're under the toggle editing, but on the advanced digitizing toolbar, there's a move feature button. So it should be the second from the left here. And if you click on that and then click on the polygon that you want to move, you can just drag it to a new location. So if I'm happy with these ones, I can toggle editing off in order to save them. It will ask me, do I want to save changes? Let's save it. Now if I try to do anything on the digitizing toolbar, it's not going to allow me to do anything. So I'm going to go back to the main view, and I want to actually add these same polygons to these different areas of the field. So the easiest way to do that is you could, again, make the polygons using the tools to create a polygon feature or to create a rectangle, or we can copy and paste these ones. So in order to do that, I want to make sure this one is highlighted, the shapefile, and then go back to editing it. So in order to copy it or make a change to it, I need to select it. And so in order to select, I want to be up here on this button. It's select feature by area or single click. If I click on that, I should be able to click on a polygon, or I can draw a box and it should select both of them. The one problem with copying and pasting is it's also going to copy and paste my ID variable or whatever variable I've entered into the shapefile. So I'm going to copy these and I have ID 1 and 2, and then I'm going to have ID 1 and 2 for the other ones as well. So the copy button is right here. Just copy feature, or Control-C on Windows. You can also, if you wanted to, just delete the selected area or cut the feature to copy and then remove it. So I'm just going to go ahead and copy it. And if I paste it, it says they were successfully pasted, but they're just right on top of the area that was already there. So in order to move them, I'm going to have to select them and then move them. You can just move them over to this area. And actually, I accidentally selected all of them because I drew the box and it's selecting everything underneath it. So if you haven't made a save, you can always go back and undo. But once you've saved your shapefile, it's not going to allow you to undo those changes you've made. So at this point, if I do Control-Z, I should just go back. And I can unselect everything using this unselect button to the right of the select button. I'm just going to move them individually. Select one and then move it over. Everyone wants to try to do that. Probably the fastest way to do it. And then I will again copy these, paste them, and then I can just move them over here. So I'm going to do a check-in, make sure everyone is at this point. If you are having trouble getting your shapefile and situating it where you want it, you can always open the shapefile that is in the downloaded data file. But before we move on, we want to make sure we save any changes we make. So make sure you toggle editing off and save, and then put up your green check mark if you are at this point. And I think we've had on the schedule that we'd take a break from 2:50 to 3 o'clock. So I'm gonna stop moving forward for 10 minutes. But if anyone has any questions, I'll continue with the demo of actually extracting the data with this shapefile and then creating the high throughput shapefile at 3. Okay, so I think everyone hopefully is back from the break. I'm gonna start back in. Maybe I'll try to answer the error message question first. How are the error messages in QGIS, and are they more helpful than the ones in ArcGIS? Sometimes, but it really depends. QGIS is written by a lot of different people because it's open source, and so there is some standardization, but a lot of the times I use different packages and pull them in, and some of the error messages are helpful, but a lot of them are not, unfortunately, and that's when I just search online mostly. I don't know if anyone else had any other experience, but mostly I just Google the error message because they're not very descriptive. But if everyone's back, I'm going to start with number 4 here under the multispectral data extraction. We're going to add metadata to the shapefile. So in QGIS, we could open the attribute table by right-clicking the layer and then going under Open Attribute Table. So right now you can see, because we copied and pasted, we kind of created this problem for ourselves, but we have IDs of just 1s and 2s. But it also, we can identify which one is which by just highlighting the row here. And you can see that this row corresponds to this shapefile, or not that polygon. So in order, we do want to probably add some metadata that defines what rep or what treatment each of them are. For me, right now, these are green boxes, and I can't really tell what's beneath them, and I want to be able to see those dark green squares that are the nitrogen squares. So before I go any further, I'm going to adjust the properties of my shapefile and make it so that I can see through and just have the outline. So if you, just like we did on the raster, if you adjust symbology, you could change the color, add different things. You could even do the fill based on a value of the attribute table, but right now we don't have any values. But instead, I'm just gonna get rid of the color. So it's just a black line around the outside of it, and I can see what it is surrounding. So if I go back to the attribute table now, I'm going to add 2 columns. And in order to add columns, I have to toggle the editing back on. And then I can go over here. You probably want to see this still. Under this gold button, or to create a new field, it's also Control W. So I click that, it's gonna ask me to add a field and give it a name. I'm gonna name this one treatment, because right now I have 2 treatments in this field. Is it either nitrogen rich area or just the regular field area, which we call the field rate. And so that treatment, it's not actually a number, it's more of a factor variable. So I'm going to give it a text, and you want to make sure you really pay attention to the type and length as the other field, because those are not you'd have to delete the field in order to reset those. You can't change it once you've created it. So I'm gonna give myself at least 20 characters, say, and then I have a treatment field. So now I could add in there, if I highlight here, I know that's the field rate because it's not over one of those dark green areas. And then this one is an enriched strip. You're gonna do that for each of the sections. In some of these, we also take GPS points, and I could import those to create a shapefile. But for this image, you could clearly see which is which. We can just highlight each one to kind of see where we are. So I also care maybe that this is rep 1 in the bottom right-hand corner, rep 2, rep 3 is the top. So I'm gonna add a rep as well. So again, I can add a new field, and this time I'm gonna name it rep. And this one is an integer, and I only want it to be length 1 because it's only 1, 2, or 3. And then I know that's actually 2. This one will be 1. And this top one is rep 3. So it's important to have metadata that allows you to identify which ones are which, and then be able to export this data, which we'll get to eventually, of the values that are within each of these polygons, to then put it out as just a CSV table and still be able to use that data. I don't really care about this ID column anymore, so I'm gonna actually delete that field under this red delete field, and it will give me this list of fields to delete. I can choose ID and press OK, and it should disappear. Once I am happy with that, I can toggle editing mode off and save. So I should have all of these, and then I can get out of the attribute table. So the next step is we're going to use this processing toolbox. If your processing toolbox isn't showing up on the right, you can go under View and then Panels. And the processing toolbox is a panel. Some of the processing toolbox algorithms are also under raster or vector at the top. And if you used QGIS previously, a lot of the old things that were plugins are actually now built-in algorithms within the processing toolbox. So the one we're going to use is called zonal statistics. And pretty much what it does is it uses the shapefile we created just like a cookie cutter, and it cuts the area below the shapefile for each of the polygons and summarizes the data with whatever kind of function we give it, whether we want the mean, the standard deviation of those values underneath the shapefile, and then outputs it into the attribute table for us. So in order to find zonal statistics, we can go under the raster analysis, but honestly, the easiest way is to use the search bar. And if we just type in zonal statistics, you can see that it is under raster analysis. It's also in my recently used area. But I'm going to go right here and double click it to open it. You should get the zonal statistics window here. So we're going to run it for just this one image, but if you ever want to run it for multiple images, you can also run this zonal statistics as a batch process and do it for a bunch of shapefiles, a bunch of images all at once in parallel. So for this one image, we're going to want to select our raster layer, as well as the raster band. You could do this if you had a raster stack with multiple bands, but this image was actually stitched in Pix4D, and I created the NDRE within Pix4D before exporting it. So it only has one band. And then I want to make sure I have the correct shapefile. We only have one right now. The output column prefix is just going to be what's before whatever statistic you choose to calculate on the attribute table. And a lot of times I'm extracting more than just NDRE, where I have many different rasters. And so like Sean and Andy talked about this morning with organizing your data, you want to kind of have a convention of how to put your prefixes of your columns. And I always put whatever index I'm extracting as the prefix. So I put NDRE here since we're going to be getting NDRE data. So if you click the little dots here, we can choose from the list of statistics to calculate. There's a wide variety. You could say calculate all of them, but really what I'm interested in maybe is the mean and the standard deviation. So that's going to give me the mean of, for each, the mean of the pixels of the raster image under each of the polygons in the shapefile. If I click OK and run, it will run the zonal statistics algorithm, and it will look like nothing has happened. But once it rose all the way to 100 and then goes back to this, it's done. If there was an error, it won't show up in your attribute table. If we close this and now I want to check the attribute table that the statistics are actually there, we can open it back up. And so you should have, I have NDR mean and NDR standard deviation as two columns that correspond with each of the polygons in the shapefile. So green checks if you are there, red checks if you need more time or have a question. Okay. Let's see, mostly green checks.
It's looking good.
Yeah. Okay. So once you have this piece, all this data extract that you want, usually what I want to do is pull it out and then use it in a statistical software such as R or Python. So in order to do that, I'm going to just export it as a CSV, and you can actually right click here on your shapefile and then go to export to save feature as. So at this point, you have the opportunity to use, save it as a bunch of different things. We can save it as a different geographic format. We can save it as it's still as a shapefile, but change the coordinate reference system. But we could also in here just save it as a CSV. And so that's just going to pretty much save just the attribute table. I don't want to include my CSV in the map, but I can also change, if I want the separators to be common, I could get a tab delimited file if I wanted. But again, I need to set my file name. This is NDRE thing. And then press OK. So I go to that file. It should look exactly like my attribute table looks. So then I can pull this and use it in any statistical software pretty easily. Okay. I think I've got through everything that I wanted to there. I'm going to go to the next part. It's meant to be more of a demo than a follow along. If you wish to try to follow along or you have some experience, more experience with QGIS and R, you can follow along if you want to. It's the instructions on how to do it is in this multispectral data extraction high throughput section. So I'm going to create a shapefile using an R script that creates a bunch of shapes that are uniform in distribution as well as size and shape. And then we can do the same thing by extracting the data with the zonal statistics. This section does require R. QGIS works with Python as well in a very similar way as it does with ArcGIS, but it also works with R. It pretty much runs R in the background. It does not have its own R within QGIS, so you have to have R separately installed and all the packages separately installed as well. The one trick is if you update R and you haven't updated the R within QGIS, a lot of times you'll get an error saying, I don't have that package, when it's just you don't have the updated package in QGIS, and you might have to delete it and reinstall that package. Okay. So for this one, I'm going to use a different raster layer. So I'm going to open a new project and add a new layer. Use this GRVI, which is in the downloaded data. And so this is a trial that I help run, and it has been run for many, many years in the state of California, testing varieties of wheat. And more recently, we've been phenotyping these varieties on a pretty frequent basis. And so we want to get information on each single plot in a uniform way, and we want to get that throughout the season, almost every week in some cases. So the question is, how do we do that without drawing and digitizing each plot? So in order to use R within QGIS, you need to have the R plugin. So if you enter plugins and manage and install plugins, it might take a minute to connect it. With a plugin, many people can create plugins. They're kind of like an R package. And you can search within here to look for different plugins. It's called R processing. I think it's called processing R, actually, sorry. Processing R provider, right here. So I'm not going to install a new version right now, that'd be terrible. But if you have it checked, that will install it and press OK. The one thing is, if you are just installing a plugin in R, like the R plugin for QGIS, you will have to restart QGIS in order for it to take full effect and for you to be able to use it. But once you have it installed in your processing toolbox, you should have this little R up at the top. You can see there's a Python script button as well as R script. So if I go to R script, I can create an R script, and I could create one from scratch here to do anything I wanted, or I can open the script that is in the downloaded data processing scripts. I'm not going to actually open it, but I can show you in this downloaded data, there's R script, and you actually use an RSX file, and this is called the small plot trial extraction. So you could open it there, you could save it, and the one thing is you'll want to save it. If you save it in your documents or whatever, it will be there accessible just one time. But if you save it within your QGIS file structure, then it will show up here under R, so that you could always click it right here. So this R script, I actually creates a processing window similar to zonal statistics or some of the other tools that QGIS use. And the one thing it asks for you to have to input is an origin file. And so the origin file is going to be the point at the corner of this trial. So in order to create an origin file, I'm just going to create a new shapefile like we did. Add create shapefile. I'm going to save it. And I created an origin if you're following along and want to just load this one that was already created, you can. And again, you want to make sure your coordinate reference system matches. And then this is a point shapefile rather than a polygon shapefile. And if I edit it, and I'm going to choose the edges of the field that I want to create the shapefiles for. So pretty much it works on anything that is evenly distributed and continuous. So I'm going to look first at this field right here. And I don't want to look at the edges because the edges are kind of just the buffer rows. So I want to create points along the edges, enable them 1, 2, and then I'll have ID 3 at the top. This one's actually 10 rows high. So once I have 3 points that define the spacing of the trial, but also the angle of it, I can save those origin points in order to input them into the small plot trial extraction. The background behind this is in this R script right here. And so pretty much what it does is it's just going to calculate the angle of those points. It's going to take whatever you give it as the number of rows and ranges, which is pretty much the number of rows and columns of the trial, as you can give it a length and width of the plots if you want, but otherwise it'll default to 60% of the area that it assumes to be a plot, assuming there's no spacing between plots. And then you can make it rectangular or circular if you had circular plots or trees. If I execute this, I have an origin. This one has 20 rows and 10 ranges, and I'm happy with it saying that 60% of the length and width will be that. I don't need to put a radius because it's not a circle. If I had if I unchecked rectangular and wanted a circle, then I could put in a radius. And it's going to save it as a temporary file if I don't save it as a file here. So I press run. It will take a minute to calculate where to put everything. Then if you close this, you can see that it was created a shapefile for all of these different plots. It also labels them so they have unique IDs. If I go into the attribute table, I can see that they have a plot number, which in agricultural applications, it's very typical for the plot number on the bottom left-hand corner to be plot 101. So that's the default here. If you choose a little I symbol, identify feature, I could click on a feature and it will tell me that that's actually plot number 101. And so then when we extract data with the zonal statistics, it will have those as uniquely identified pieces of information. So it isn't this isn't perfect. Sometimes some of the plots, we don't use a GPS tractor, but if you're in a production setting, it might use a GPS tractor or something that makes it more uniform, but you can always adjust these, like we showed earlier with the manually created shapefiles. So you can select, you know, just one of them and edit and move it. And then you just want to be careful that you don't move it out of its position, because that one is called a certain plot with a certain, you know, row number and such.
Taylor. Oh,
yes.
Oh, you were probably going to
Sean
say
and
this.
I are going to say the same thing.
Go for it.
A couple of people are actually following along.
Okay.
And they're all getting the same error. I don't know if you've encountered it, but you can look in the chat, but it says the script has syntax error and variable name rectangular. I think it's the same Boolean error that we were getting, or that I was getting as well at some point.
Yes. Okay, so I kind of wanted to do this as a demo rather than a follow along, because there's so many errors with the R and stuff within QGIS. But I'll say I fixed this error because I have R 4.00, and then that is a newer version of R, and then this is a newer version of QGIS that we're working off of. And R was actually not running the part of it correctly, because it was trying to use the like SP package from, even though it works in R, if you have a package downloaded from a previous version, in QGIS it won't work unless you have the package downloaded within the most current version of R that you are using. I think that might solve it, but if you...
There's a link on the agenda to download the newest R version as well.
Mm-hmm. Yeah, so where it's like getting this rectangular equals Boolean is right here. So all it's saying is that a yes, no, is it rectangular or not?
So someone's saying that they downloaded everything yesterday and they're still getting this same error.
Yeah. Yeah, it's hard to, there's a lot of configuration on like QGIS and R and on different machines, that if you don't have things in like a different file, it's kind of iffy.
Right.
Taylor, you're gonna say something?
Yeah, so, and they need to download that RSX file into it's like is it where you would usually save for a plugin in QGIS?
Yeah, so I mean, if you want to, you don't have to use it, like save this within your QGIS file structure if you only want to use it, once, or you want to just open it from the file structure every time. But if you want it to open in QGIS, you do want to save it within QGIS, and it's usually under this, it will open up as your automatic place, usually, but not always, as you're processing R scripts in QGIS. And then once it's saved under that, we'll keep turning up there.
So given that you didn't really anticipate people doing this part of the workshop hands-on, maybe just proceed as a demo. But I think the take-home message is that there are configuration steps to do with R, which includes not just this plugin within QGIS, but installing all the packages within R. And then R, just within the last 30 days or so, they upgraded to a new version. So some of the packages are catching up.
Yeah. I mean, that was pretty much all I had to show. There wasn't too many questions stopping us. We flew through it pretty fast.
Just as a side note, I used to double up my workshops and create workshops in both ArcGIS and in QGIS for each session, so people could basically choose their adventure. The why I stopped is because I'd show up one day and they'd change things since the day before from when the version of QGIS was developed. And sometimes the integration with the various tools, not just R, but like the grass tools and so forth in the tool functions, they just would stop working or they would be somewhere else. And so I'd found that I sometimes would have to uninstall everything and then reinstall everything, and then it would work. And why that works, I don't know. But just as an aside.
Yeah, no, it wasn't working for me about 2 weeks ago, and I uninstalled all my packages in R and reinstalled all of them as 4.0 packages. So I don't know.
Yeah. But this connection is really cool, and I have a feeling like tomorrow as we wind DroneCamp down, we'll have a discussion about like what else would you like to learn. So if 20 people say we'd like to learn more about integration of R and ArcGIS and R and QGIS, then maybe we can get Taylor back later in the summer and the fall to do another workshop where we do go and make this more of a hands-on part.
Yeah. I hope there's more questions and all. Otherwise, we're the one session that doesn't go overtime.
Yeah, how do you like that? Does anyone have any questions for any of us, for that matter? Any kind of questions? Data, you name it.